2, 1. And we are live with tonight's session of Meeting C++. Somewhere is an echo of mine. I need to see that. Okay. Can you hear the echo, Daniela?
I don't hear any echo.
Okay, that's probably on my somewhere.
But your camera is defocused.
That will correct itself again. Okay, a little technical problem. I will just leave. I cannot leave that. So a little bit of a technical problem because I have an echo here, which annoys me, but yeah, it seems to be gone now. Okay, so let's get started with the session. Tonight, our guest is... No, wait. Hello and welcome to Meeting C++ Live. And tonight our guest is Daniela Engert, who is in the committee with modules and has been keynoting last year Meeting C++. So there will be a lot of questions, I think. If you have any questions in LinkedIn, post them please in the chat. If you have any questions in Hobilo, please post them in the Q&A tab. And if you like a question in Hobilo, please upvote the question. With that, let's get started with tonight's session. Daniela, nice to have you. Thank you for coming, and please introduce yourself.
Thanks, Jens, for having me. I'm very pleased to be on your show, and I'm looking forward to an interesting evening with lots of interesting, controversial, entertaining questions. I'm looking forward to all of you. And a little bit about me, for those who don't know me yet. I'm an engineer from the profession. I'm an electrical engineer. Everything is self-taught regarding software development. Started developing software 40 years ago or so. And yeah, I'm working at a very small company in my hometown, Nuremberg. We are doing special machinery for quality inspection systems in the industrial context. And there I'm developing all of the software from the DSPs up to the visualization on the screen and this kind of stuff. And everything is in C++. There's nothing else besides possibly a little bit of C on the embedded side or in the FPGAs. And yeah, so this is my background.
I see, and we have the first question. So I do want to say, if you put your questions in, the limit is 200 characters, which I can post to the video. Okay, so please don't have your questions be too long. The question is, while C++ is used from microcontroller world to enterprise distributed systems, shouldn't the CPP reference documentation include the safety of these RPs? Example, if certain RPs could be used in thread signal handlers, interrupt handlers, etc.
Can you put a question into...
Yeah, I'm trying to.
Banner, please, because it was a little bit long.
Yes,
it got it something about C++ in the embedded world, and
yeah. So think it's a question about RP documentation. So now we go. Shouldn't the CPP reference documentation include the safety of these RPs, which are in the standard example if certain RPs could be used in threat signal handlers, interrupt handlers, etc.?
Yeah, I think this is a good idea to actually document this kind of stuff on CPP reference. Maybe it's not too common to use C++ in the embedded world because of the lack of support in the compilers. So maybe the people who are maintaining the wiki sites on CPP reference didn't feel to put too much effort into also including this part of information. But if you look at the standards document, you will find information about, for example, threat, safety, signal, and interrupt kind of stuff. But in many cases, you have to be aware of the fact that in embedded, you not necessarily have an operating system underneath. This is one thing. And the other part is your tooling that you get for your maybe microcontroller or an embedded controller or whatever kind of system you're programming for, don't support actually developing with C++ on this platform. I've been bitten by something like that, 5 years or so ago. GCC would have been totally fine with programming in C++, but the toolset didn't support it. So it's probably more of the documentation of your toolkit for the device that you're developing for, and to look for this information over there, because it's you have to look at the particular implementation of API functions from the standard. Many things are not necessarily defined in the standard when it comes to freestanding implementations like embedded world.
Yeah. Also, I think it would be news to me that you're involved with cppreference.com. I know that some committee members are, but I think like this is like a bit of out of context. I see that on LinkedIn already. Someone is asking like who is putting the examples there, and C++ 20 examples are still missing. This is a wiki project, and actually I think most people would be able to contribute to it. So if you think something is missing and you can contribute to it, try to join the effort there. And we do have a question which I quickly want to show from LinkedIn. When it is necessary to use C++ instead of Python?
Oh, I don't think it's a question of necessary or not. If you want to use Python, you're probably not in a system or an environment where the memory footprint or the performance profile is of too much importance. This is not a situation that I'm in. I'm using C++ only because we develop system software for machines, and we have a restricted amount of memory, and we have a restricted amount of CPU power, and we need to spend everything on the actual functionality, so we can afford put more work into the software development, and this is the reason why we use C++ instead of Python. Many things would be much easier to implement using Python, but it wouldn't help our customers.
Okay, let me... Okay, so I notice many safety coding guidelines, including Google C++ style, prohibit exceptions. What are your thoughts?
I'm not sure if the Google C++ style guide is actually a coding guideline, but my thoughts on exceptions. Yeah, it all comes down to the question of how predictable is the execution of your code in terms of performance, deadlines, and this kind of stuff. Using exceptions makes error handling quite easy, at least on the side where the exception is the error condition is detected and you throw the exception. It makes it more difficult on the catch side. You probably don't know what kind of exception you're dealing with and what the additional information required to actually learn about the exception is, and you're probably missing this kind of information. And you need to be aware that the typical implementation of exception handling is not bound in the memory space and also not bound in the latency space. So if you're not throwing exceptions, your code is very fast in the non-exceptional case. But if you have exceptions, you had to be aware that the amount of time to actually catch the exception is virtually unbounded. And this is something that not every system can afford. For example, if you're into machine control or into high performance trading or this kind of stuff, you have upper bounds of time that you can spend on handling your errors. And in this case, you probably don't want to use exceptions at all. And so many systems where you want to have guaranteed performance profiles, you will probably not use exceptions. When I look at my code, I'm a little bit in between real-time computing and nothing matters. I do use exceptions in parts of my code, but there are also code parts where I totally don't use exceptions, but rather use error return type like return codes or the expected type from C++23 or this kind of stuff, because I know in advance how long it will take to actually handle these kind of problems. So these are my thoughts on exceptions. It depends on the environment that you're in, and it's not the only way to deal with problems in your code or in the outer world.
Yeah. So we have another question from LinkedIn. Isn't C++ getting unnecessarily complicated as more features seem to be glued to the language? Seems that it becomes almost impossible to memorize best practices as there are so many corner cases that it's discouraging. Maybe it's time to make C++ not backwards compatible.
This is a loaded question. Yeah. There are actually multiple questions in here if I read it.
Yeah.
So unnecessarily complicated. I don't think it is unnecessarily complicated. The complication that many people perceive from C++ is because we have to cater to many different needs. We have the people from working in very old code bases. We have the people who want high performance kind of stuff. We have people who want it to be as easy as possible to program in. And all these different stakeholders have different ideas how the language should look like. And for people who only use one aspect or have only one point of view, this probably sounds like unnecessarily complicated. But this complication has a reason. On the question of being it almost impossible to memorize, yeah, I don't memorize everything. I can't. I'm just a human. If I need a particular kind of feature, it's enough to know that a particular solution for or multiple solution for a feature or a problem exist, and then I go out to a CPP reference, for example, or in my case, I even look up the standard text by itself, and then I will learn about what I can use and what I best use or possibly avoid when I'm in a particular situation. And the corner cases, the corner cases are something that you see a lot in the social media. People are bragging about what clever solution they have for a particular very specialized problem. And you look at it and say, oh, you're exploiting this particular dark corner of the language to present a particular solution. And my opinion on that is don't be clever. The simplest solution is in most cases the best one. And in particular, it's the best for you because a half a year in the future, you probably don't understand your own code if you're too clever. And the last part, is it time to make C++ not backwards compatible? Yeah. If you've been watching my talks that I've been giving over the past couple of years, in the closing slide, there always came a sentence up where I was advocating for actually breaking backwards compatibility. In my opinion, it would be beneficial for the community at large to not put so much emphasis on backwards compatibility as it has been in the past 20 years. Well, 20 years ago, we had not too much of backwards compatibility because C++ was still quite new after the delivery of the first standard. But now, 20 years later, we have accreted a lot of old things that we learned are not really the way to deal with particular problems. But we have to keep them just because the code exists out there. And if we don't have a very, very good reason, we don't want to break this old code. But now, with C++ 20, we have a new feature that actually gives us both backwards compatibility and a good way forward into the future. And the feature I'm talking about is modules. In modules, you can separate code, which is following the traditional way how to implement things in C++ and be backwards compatible. And on the other hand, you can write new code, which doesn't have to look at backwards compatibility. And I think this is a piece of the language where we can actually go out and say no particular language constructs are no longer backwards compatible. And if you look at the experiments in the Circle compiler, for example, or in the ideas that Herb Sutter was proposing at CPPCon, this CPP2 front compiler that is very keen on breaking compatibility with the past just to make a way towards the future. I think this is actually the way to go with C++, but you need to be you need to accept that we have a new kind of feature here, modules, and actually be ready to use it to give us the opportunity to go forward in this kind of direction.
Okay. Let's carry on with modules. What is the status of modules in C++ 23, and what's like the outlook for?
Okay. I see it that we have the language side and we have the implementation side. I can't tell anything about C++ 26 because there has been no work on modules for C++ 26. In fact, the work on modules is more or less finished, and we are just working on figuring out particular use cases which have turned out to be a little bit limiting in what we can do with modules. And this is what is now in C++ 23. When it comes to implementations, if I want to be honest, no compiler has a fully 100% conforming implementation right now. I'm using modules in our company on a daily basis, but I'm in a very special situation that I can work with just one compiler. We are targeting Windows only with the Visual Studio compiler, and so we can take advantage of the quite good implementation of modules in Visual Studio. When it comes to GCC and Clang, the situation is not as rosy as it is in MSVC. I've been experimenting in the last few months a little bit more with GCC 12 and Clang 15, and it looks like, yeah, things are coming along, but not as quick as many people would probably hope for. But I'm quite confident that in particular Clang 16 will be a huge leap in regards to the implementation of modules. In particular, just as of yesterday or the day before, there is a patch merged into Clang 16, which should make it possible to use modules with CMake and Clang. So this is probably the latest stuff that I can tell you about the status of modules in Clang and possibly GCC. If you want to know something more in depth, you probably have to ask me a very detailed question.
Okay. Let's go to the next question. By returning std optional or std expected, are there less reasons to use exceptions?
Totally so. Both of these types can help you handle cases where you can't fulfill your post conditions. For example, you can't produce a result, use an optional. And if you can't produce a result and have information along why you can't produce the result, you stood expected. And these are probably cases where you would have been using exceptions in the past. If you can handle situations where your function call cannot produce a result, so it can't fulfill its post conditions, it's probably a very good idea to widen the contract here and use an optional and expected type, in particular if you're able to handle this error situation very near to the call site. So I totally recommend use optional and expected.
Yeah,
You can also use optionals if you're in a situation where you use a deferred initialization. This is another use case of optional, which is probably not too well known. It's not just about return types, but you can use it also in your objects itself to defer the initialization of parts of your class to a later place and a later time when you know more about the situation where you want to actually construct a part of your class. The other piece would be anonymous union, and it's something that hardly anybody knows about.
Okay. There is a question about career. How do you manage to stay in hands-on design and coding all these years?
Okay. I managed coding all these years. Yeah, it's my job. And to stay hands-on coding in design, yeah. What's really helpful has been trainings from Scott Myers in the early 2000s, in particular attending Meeting C++. I can only highly recommend going there, and also other conferences. But Meeting C++ is really a conference where you should go if you possibly can. And then there are also all these YouTube videos from other conferences with very bright people and highly focused and talks full of information that you probably never heard about and can put into your own work. And so this is the kind of stuff that I can recommend. And then there are books. I have been really happy to review Klaus Igelberger's latest book about software design. And by reviewing this book, I refreshed my knowledge on software design and design patterns and how the application of all these good ideas, and put it straight into my code that I'm writing these days. And this is something that I only can recommend. Buy this book, visit conferences, read blogs, and watch YouTube videos.
Yes, so there's a question which you just saw, and I want to use this question, but yeah, okay, I see. Format and ranges. Okay, let's see. Many major C++20 features are still not implemented in some major compilers, e.g. format and ranges in GCC and Clang modules in both. And do you believe that the Big Bang for C++20 is really our reality today?
Okay, I can see from the question that is something, some person who had seen my keynote at either CPPCon or Meeting C++, where I was talking about Big Bang C++20. Yeah, format. As far as I know, both GCC and Clang have it now. Even though the quality of the implementation is not as good as it is in the format library itself. Actually, this had been a topic of a paper in the latest standard meeting in Issaquah. Ranges, yeah. I'm a little bit torn about ranges. Ranges is a vast topic. You have the range-based algorithms, you have the views, and I think the algorithms are probably not in too bad shape in GCC, but I'm not well versed in GCC, so I can't say much about it. But my opinion on ranges is I have mostly a hard time using parts of the ranges standard in my own code. In many cases, not using ranges is actually simpler, particularly the range views, but it could be me. So I'm not missing the ranges. I wouldn't be missing ranges too much if I wouldn't have it in the standard library of a particular compiler. Well, modules is a different kind of thing. I wouldn't start programming anything without modules anymore. But if you're not using too difficult kind of stuff with modules, you can actually use it both in GCC and Clang today. I've been trying it out and it works. And I've been in contact with people who are using modules with GCC and Clang. And yeah, you need to be aware that you can run into implementation errors, but you can use it and you actually should do it because modules are the best kind of thing to structure your interfaces. Modules are not about making your compilation faster. It's about making your code better and your interfaces more concise and better thought out. And so you should use it. So if you really want to, you can use all these Big Bang features in C++20 today. This is my opinion. But also, as always, it depends on the situation that you are in. Probably not many people are actually able to use the latest version of GCC or the latest version of Clang.
Yeah, I think that's the other big problem. Is, like, recently I installed on my machine GCC 11, and that's basically the last thing I can get. That's the latest version.
Yeah.
12 is not available. I would have to build 12 from source, and 13, well, 13 is the future.
So which kind of standard do you have in your compiler?
I think with GCC 11 now, I'd be able to move to 20, the good parts, and
Okay.
C++ 17 then. That's my plan for how to do C++ internally for Mini C++ and my projects.
Yeah, but if you want to do yourself a favor, go at least to C++ 17. Everything before 17 is no fun at all.
I used Qt 6, and with Qt 6, C++ 17 is fully supported or is actually needed. And also recently there has been a talk by Mark Mutz released on using Qt 6 with C++ 20. And I was like, wow, that's really interesting, because Mark Mutz is working for the Qt company, and so it's like the official statement that yes, you can use C++ 20 with Qt 6, and
I'm doing it on a daily basis.
I'm going to exploit that as much as I can, of course, because the other thing which I had hoped for, that maybe deducing this would be already implemented, but that's still missing from Clang and GCC, I heard.
The next compiler versions of Clang and GCC should have it, and MSVC has it right now, but not in modules yet.
Oh, what do you mean it's not in modules?
If you compile with modules, your feature macro will tell you, no, we don't have explicit object parameters.
Okay.
So you only have it outside of modules. And the thing is that, as you probably know, MSVC has a very structured format for the modules, the BMI, the binary interface. And deducing this is a different kind of function representation, and this requires extension of the IPR in the BMI, and this is not yet implemented there.
Oh. So this feature macro actually is enforced if you try to compile to a module. It's not like theory, it's not there. It's also in practice not there.
So you have to implement this without explicit object parameters and with explicit object parameters, and have to select the code path according to the value of the feature macro.
Okay. Apart from C++, what languages have you enjoyed programming in, and which languages would you like to learn?
Okay, let's have a look at the clock. Okay, I have 20 minutes. Yeah, just a short overview in order of learning. Fortran, COBOL, BASIC, Pascal, Forth, Occam, Java, C, and tons of assembly languages and very specialized languages. And then the hardware description languages like VHDL and Verilog. And what I would like to learn, maybe I should look a little bit more into Rust, just to get an impression about what it's all about, programming in there. And another one that might be very interesting is Haskell, and possibly Erlang. Okay,
there. We've been touching on the committee, and there is a follow-up question from LinkedIn. Let's deal with that. You mentioned that C++ needs to handle many corner cases as client users devs asked for them, but isn't that the definition of scope creep? And I think this is a misunderstanding, right? Because we have 3 different implementations which bring their own scope creep with them. So,
well, it's not just 3 implementations that we have. We had at least, let me say 5 or 6. We should not forget EDG, we should not forget ICC, and we should not forget Circle. In particular, Circle is very interesting to look at. And I don't know if this question is actually related to the standardization process.
Yeah,
people probably don't really know about how the C++ standard is made. What's going into the C++ standard is stuff in form of papers that are presented to the committee. Everybody can write a paper and submit it to the committee for thinking about the ideas proposed there and figuring out how to incorporate it into the standard if it actually finds enough people to champion this particular feature. And I don't think this is probably characterized as corner cases. C++ is a system language that has a very wide applicability in many industries. And so I don't think we should limit ourselves to a particular domain only. So with this wide scope of users that we like to address as a systems language, we have many, many people from very different backgrounds and different needs. So I wouldn't actually call this a corner cases. If a proposal is too limited in scope that it makes absolutely no sense to spend time on discussing this paper and find wording to incorporate it into the standard in a consistent way, we don't do that. So I don't think this is scope creep. It's actually use cases that are brought to the committee to give help in using C++ in these particular domains. This is my opinion on this kind of stuff.
I think with some of the new features, it's also that we cannot like release the full feature in the perfect shape with the next standard. I think coroutines are a great example of it, that the coroutines in the C++ standard will be improving with every standard, but at the current point, it's still very much a manual mode, and that you need to add a lot of things or use libraries which add those things to the standard, which later will be in the standard. And so let's move on to the next question. How will these new features affect the overall performance of C++ programs?
From my personal experience, the performance increases. In particular, as I've been alluding to a couple of minutes ago, C++ 17 was a major inflection point in regards of performance. If you don't know or haven't noticed, with the advent of C++ 17, we have the guaranteed elision of copies of return values. And you compilers can do really cool kind of stuff with C++ 17, and also with the increase of more cases where you can use these performance increasing features in C++ 2023, and we're looking forward to 26 as well. So I think the runtime performance of C++ increases with every new major standard. This is not necessarily so the case with the compile time performance, unless you really let all old solutions to metaprogramming go. For example, Spine is a major bummer when it comes to compile times. Just embrace concepts, and your compile time is as good as it has been in the past.
Yeah, I think the committee is usually only adding things to the standard which are not like really slowing down things. That's, I think, also one should probably know about the standardization process does take a look at this. And
yeah, there are now with with more emphasis on security and safety, we are actually discussing papers where we might experience, or at least we think we may see performance degradation because of ruling out undefined behavior and replace them with defined behavior. And if you are removing undefined behavior from code, compilers can no longer exploit undefined behavior to do weird optimizations. So you need to be aware there's a drawback. You can either increase safety and security in your program, or you can even go even farther and give compilers even more freedom in optimizing away stuff that I think is code that you have written without really understanding the language, and they're punishing you to death with what they actually compile from your code. But the features itself usually are meant to increase performance. And I think it's a good thing to not let users fall into traps with corner cases in the language and undefined behavior, that they thought this is something that gave them performance, but actually gave them only unsafety.
Okay, the C++ ecosystem now has a lot of package managers and build systems. Is it high time to have a standardized package manager and build system to put C++ forward by the standard?
Yeah, there are multiple things in here. For one, the C++ standard itself is a standard is a document describes the language and the library. It doesn't describe anything about the implementations and the ecosystem around it. It's just not the scope of the standard. So it will never be in the C++ standard. Having said that, we have the study group 15 in the committee, and I'm also a member of the study group 15, where we are discussing things like package managers, build systems, and what we can do to improve things there. But even then, we will never come to a point where we'll be a standardized package manager or a standardized build system. We don't want to do that. We think it's a good thing to have competing implementations of a standard. Platforms have different needs, industries have different needs, and we don't want to prescribe a particular package manager or build system. Even worse, we would have to then provide a implementation of a package manager and a build system. This is something that we totally don't want to do that. All members in the standard are basically volunteers or part-time members who can dedicate a limited amount of time on this kind of stuff. So every implementation of everything, and this includes package manager and build systems, must come from vendors or groups outside of the committee, and usually this leads to multiple implementations of package managers and build systems and different thoughts on how to actually do this kind of stuff. What we can do is encourage using standardized metadata formats. For example, there is a new standard on how to describe dependency information, not only for modules, but for everything. And this is actually has a paper and is implemented in for example, CMake and compilers are writing out dependency information in this kind of standard. This is what we can do in the committee to improve things related to package managers and build systems. And yeah, there will be probably a international standard put forward, possibly in 3 years' time from now, where you can see a comprehensive, standardized view on the system of package managers and build systems. It's not neglected in the committee, but we are limited in what we can do.
Yeah. And I also think it's like C++ is not an organization, right? We have the ISO committee, and then we have various compilers implementing the standard, and build tools and package managers is something which we take into existence now for the committee, but the committee will never be able to actually like standardize software. That's not their job. So and when we're talking about the committee, how to be part of the C++ committee, and how can, as a user, share my experiences to language and new users?
Oh, let me try to... We actually have two questions here.
Yeah,
being part of the committee and how can as a user share my experience in language and new users? I don't really understand this sentence, to be honest.
I have a bit trouble with the second question too. Let's go for the first question.
Okay, let me talk about the first question: how to be part of the C++ committee. Okay, I'm involved into the C++ committee since 2019, if I remember correctly. Yes, it was Cologne 2019. I had a chance to go there, just show up and say, hi, here I am. How's the sausage made? And let's see how things look like working in the committee. And after 6 days, I was totally hooked, and I said, okay, let's find a way to actually get in there. And yeah, if you want to be member in the committee, you need to be part of a how shall I put it? You have the national bodies, and you have independent organizations like the Standard C++ Foundation or the Boost Foundation, where you can become a member and then be delegated to the committee to work on C++. This is what the ISO process requires of you to actually become part or become a member of the C++ committee. So it's not as it has been the past 20 years or so. It's just you dedicating time and mental capacity to work on there. Now you need to be a little bit more formal in the sense that you need to be part of a different organization or body to actually become part of the ISO committee. Yeah, this is what I can say about it. If you really want to become a member, look out for your national body, get in contact with them and ask them to let them in. Sometimes you can become member of your national body for free. Many smaller national bodies don't require anything of you besides willing to actually dedicate work on it. And other national bodies require you to be a member of a an organization and you have to pay member fees or some kind of things. It depends on your nationality.
Yeah, ISO is fairly focused on industry and companies, not so much on us as users. So the second part of the question is like, how can I or they add value to the language and make it easy for new users? And so joining the committee is, I posted a link to the ISO CPP website, and I think that ISO CPP website is probably the best part to get started and to join the committee, either your national committee or ISO CPP also probably is the organization to talk to.
Or Boost organization. It may even work with the Linux Foundation. It's an affiliated body that can actually send people to the ISO C++ committee, but as far as I know, all members are part of national bodies or Boost or the ISO Standard Foundation.
Okay. What's your opinion on a possibility that contracts will be accepted for the next standards?
Oh, contracts. As I said, I've been at my first committee meeting was Cologne 2019, where contracts were ripped out of the standard. As people possibly know, contracts have been already in the C++ standard up until July 2019. And since then, people are working on getting them back into the standard. I'm not too familiar with what's going on there, and I see kind of a back and forth between two different opinions on what contracts should look like. The name will become part of C++20. There are people who say contracts are very simple kind of things that don't require too much of the expressions that you can write into your pre and post conditions, and actually put limits on what kind of expressions can be there. For example, can there be undefined behavior in the expressions that you put into preconditions? And I think this is a totally bad idea. On the other hand, there are people, in particular ones in large companies, who are using contract kind of things today in their systems, who have a more heavyweight point of view on contracts, and these people expect more functionality from contracts. And as long as these two contradictory points of view on contracts are not sorted out, contracts will not be part of the next standard. I really hope for, this is just my personal opinion, I'm more on the lightweight point of view. I want a very simple, very easy to understand model of contracts which are based on binary predicates without side effects besides possibly termination or logging, and everything beyond that is not something that I'm really keen on putting into the standard. I'm just following what's going on there, but I'm not too much into the details, because there's a back and forth between these two different kind of camps.
Yeah, and I think it's also something we should say. It's like the standardization work is so big. I mean, we haven't even touched reflection today, which I'm thankfully for. There's like not every committee member knows everything which is ongoing in the committee. There's some people which have an overview, and then there's some people which are more like working in their corner, and in the spectrum somewhere in between Daniela probably exists. So what do you consider to be the next big thing in C++? What do you, or what is missing the most?
Okay. As I already probably been alluding to in my keynotes last year, I really look forward to much more stuff being done at compile time. Reflection and meta classes. This is the kind of stuff that I'm really hoping for to proceed over the course of the next 3 years and to become part of C++ 26. I think if you want to do something like serialization, logging, you have a hard time doing it in a general way today without reflection. And I think this is something that we really can improve on. And with reflection comes much more stuff being done at compile time. I got into compile time programming over the course of the past year, and I really love it if you can do things at compile time instead of putting magic constants and other more information about configuring your classes and this kind of thing by hand. Just let your code inspect itself and act accordingly and accommodate to this kind of information that's already in your code but cannot be used in more advanced features that you can extract from this information already in your code. And another thing that I'm really looking forward is pattern matching. I'm not sure if pattern matching will make it into C++ 26, even though we are quite we have a very good shape of pattern matching, but there is a new language feature that they have to probably put into the language, and these are do expressions, which should help giving us a better way of expressing pattern matching and the actions that are bound to a particular pattern. And all these three things that I've been talking about are so big that I'm not too hopeful seeing all of them in C++ 26. And this is only the language side. I'm more on the language side, so I can't tell too much about what's going on the library side. But what I can see in the library side is the sender receivers kind of thing, and in other terms, asynchronous computation. I really love asynchronous computation, but let's see how this sender receivers kind of thing actually turns out in the end. Right now, I'm not working or experimenting with this asynchronous kind of framework. I'm using ASIO as my asynchronous framework, and I'm quite happy with it. And I was a little bit disappointed not seeing it in C++ 23. But yeah, as Jens said, the committee is big, and there are many different stakeholders with different opinions. And I see the benefits of sender receivers instead of ASIO. In particular, if you want to go into heterogeneous computing and this kind of stuff.
I think that's the other point which we currently see in the committee, that there's like some things which are so easy they just could be standardized, but they build up on something which would be outside of the standard, right? Like the socket functionality of an operating system or something. And so we have to get like in some ways right now we're trying to nail down a basic framework for asynchronous operation, and we're trying to get that right. And I'm actually quite happy that we do not like get it in 23, because it probably has been, due to the pandemic, out of the scope of possibilities for the standard. So I much rather give this a bit more time, have this a bit more seen by more people, than having that's the other problem with the current model. If we put something in the standard, it is literally put in stone. And that's also the other thing, which is the other problem, is like, once you put it in stone, you really can't remove it anymore, because that would break ABI. Or then like if we wanted to introduce a new hash map, we could, but we would have to use a different name. Maybe actually hash map is still available in the standard. That's why I'm a big fan of unordered. So we could replace it with something better.
And I think this is the beauty of C++. We don't put everything into the standard. We have so many libraries out there that we can take advantage of. I've been mentioning the ASIO library. I think the ASIO library is so fundamental today, and you can use it in so many places, but we can actually be happy that we have it and not have it in the standard. Because if we had ASIO in the standard, we would probably had a hard time to use C++ on GPUs, for example. You can't put ASIO on GPUs, but we want to take advantage of the compute power of GPUs or possibly FPGAs. And so if you need asynchronous computing, you have multiple choices to do so, and in particular use ASIO, which is battle tested and proven in time. And it's in every application that I use today and have been in the past 10 years. And so you are not limited to the stuff what is in C++. The only stuff that you can't do in in libraries is the language kind of things. And this is the reason why I'm working on the language kind of thing, so that I can have new features that enable better libraries or new libraries that you couldn't feasibly implement today. This is my opinion on this kind of thing. And so
if we look with the same angle on format, would you say that using format as a library is better than the standardized version?
Okay, so things like formatting and printing is so basic. I think this belongs into the standard library. But this doesn't stop you from using a library with more features like the format library. But I think we, as a committee, owe to all the majority of people who don't want to take a dependency on an external library just to get a decent way of putting stuff onto a terminal or format strings. Or actually, the formatting, the SUD format function is not only for formatting. It's possibly the best way to concatenate strings from pieces. If you want to concatenate, for example, 3 pieces of strings of different types, maybe a string view and a string and something from possibly a Q string or whatever it might be. The best thing is use format and concatenate this into your final string. It's the most performant option that you have. So just look at what the library function actually does and have a peek over the border of your small point of view. You see things that you can take for finding solutions that you probably hadn't thought before.
That's
And
true.
this is with many functions in the library.
Now, we are kind of having a question which is going to be about log-free. Have you used log-free data structures such as a log-free message key with C++, e.g. like what's in the Boost library? Would you mind sharing any experience working with it, like pros, cons with log-free structures in C++?
I'm pretty sure this is from Honey. Yeah, I have my own log-free message queue, so I'm totally used to log-free data structures. My experiences are limited to log-free queues. I don't use more complicated log-free structures. If I would have to, I would totally look into to libraries from the experts in this kind of area. I have been using the Boost log-free library in the past, but back then there have been problems with the atomics in Boost, and also the log-free message queues or circular queues or whatever they have been putting forward in the library didn't meet the requirements that we were having in our applications. So I couldn't use any library solution out there, so I had to do my own. Yeah, but if you don't want to go into log-free data structures, and this is a really tough kind of thing to go into, definitely use libraries, and probably the Boost library is a good start. I have been using my log-free message queues because I had different kind of polities on either end of the queue, so I had to find a way to express these different kind of policies and how these queues should behave. And this is something that's rarely addressed in libraries that I can see in Boost or in other open source libraries.
Okay. I think that brings us to the end of questions for today. It's a bit more than an hour that we're now on stream. And thank you for answering all the questions, Daniela.
You're welcome. And I was quite happy to see all this variety and these many questions. It was really interesting, and I enjoyed it a lot. I hope people are happy with what I had to tell them about my ideas and my opinions. And yeah, see you at Meeting C++.
Looking forward to that. The next guest will be actually someone who is maintaining right now Qt. So we will be touching more on maintenance and Qt in general and C++ standards, etc. Will be interesting in March. And until then, thank you for watching. Thank you for coming, Daniela. It was a nice and great evening with you. Thank you. And
Thank you.
I'm going to take us offline.